Okay, today we got a medium problem 567 permutation in string. Given two strings, return true if S2 contains S1 as permutation. Okay, and the lengths are 10 to 4. So I mean, if the length would be short, we could try permutations of S1 and check all substrings of that length, but that's only feasible for like length up to 10. So instead, what needs to happen when it's a substring is that like the counts need to, or counts of all elements in the substring we have in S2 must be less than or equal to counts here. And whenever, so we start here and we take this and okay, that's like, okay, that's over count of E in here. So we move left pointer until that count until that count is smaller, I guess. So we would move L here, right? And then if R is less than L, then we set it. And same thing here, and then we get to B, and get to O. Then it's like, that's bad. Okay, so we subtract, and then this, and then we don't find it. On the other end here, we would blah blah blah, and now we are here. And what we need to check is if all the counts match. Which we can do in all of 26, I guess. Or we can do it in all one by keeping it's quite inefficient, but if we keep count of unique elements here, and then we keep count how many of those counts we matched when expanding, and whenever we matched all, we are done. Whenever we increase, right, something over that count, then something needs to happen. And first let's try with the entire check, right? So let's do like if len S1 over len S2, because that's base case. So if the thing that should be a substring is longer than the string, then it's not there for sure. And now, so one count is counter of S1 . Let's run it. If it works, I don't know. I never used the counter thing in Python ever. So let's see. Okay. And now let's do like counter AB. Let's see. Okay, that works, fair enough. And then if we do this, okay, that's false. Okay, great. So this works. So then we do like S2 count. No, that's like a bin count counter. I think this should work. Okay, and then we can do like ij is 0. No, let's do lr. we do this. I don't know what do I call this even. I mean, I want to expand, so I want to do like while then I want to do this in count of S to L if win count S to L S while need to break if win count it means like so if win count equals S1 count, now if not stopped, this means that we didn't find anything. So we have some substring which is a suffix, but it doesn't have enough elements. But I think I'm tripping a little bit here because I just need to glide over substrings of that length. So I'm tripping a bit. Okay. That sucks. So in count is S2 len S1 if S1 win count, otherwise for I in range len S1 len S2 win count S2 I plus equals 1 win count S2I minus len S1 minus equals 1 if win count that should work. Okay, 1 edge case, no 10 edge cases actually. It's interesting. Okay, 43 milliseconds, so I don't beat anything. So let's say I have this counter of S1, right? Then I have another counter in this window, and then I do this, right? So because this is obviously slow, we are doing 0.26, which is 0.1, but who cares? So we are doing 26 at most comparisons at each of the steps. So let's see, what do we do here? Matches is this, right? So if win count S2I, S1 count S2I, matches minus equals 1, win count S2I, S1 count S2I. Okay, then I wanna check this. We'll see if it holds every time. Now if I had them before, So if the count was same, because we are now decreasing, fair enough. And if it's same now, ooh, that's tough. And now what's the problem? If let's see. Oh, that's tough. Okay. Print. Let's see. So first we have A, B, and E. Then we have EI. Then we have EID. Maybe I should do matches. Okay, so something wrong with matches. Ooh, that's quite broken, I think. So let's see, first we have -1 match, then we have -2 matches. Now when E goes, so that's we are still at -2. Now I goes out of the picture. Do I really want to do this mental athletics? Because no, matches should be 26 minus len of S1 count. And whenever matches is at 26, so the A count, B count, and E count are wrong. Here 22. Here still 22, because these four are wrong. Here it's 24, because this is wrong and this is wrong. This is 26. So why is output not true? Because I'm doing it in the wrong place. And in the worst way possible. But we got it, I guess. 85 milliseconds. Ludicrous stuff. I mean, just ludicrous, bro. For C in default dict int for C in S1 count C plus equals 1. Let's do this. Maybe a little faster, I don't know. 31 milliseconds. How is it so slow than everyone else? I refuse to believe it's that slow. Brute force. Sorting. Hash map. You wanna tell me this is beating me? Ain't no way. You kidding? Are you kidding? This is beating me? No, still not. Okay, I'm doing the same thing, my brother. Elif win count okay, and this so like this. Now in reality I wanna do this. Matches is 0. If ordered no, that's like char no ordinary of A plus I and character out of that, and then it's so stupid. What am I even doing? If what's this count from? All matches, all matches, great. I have no clue what I'm even doing, bro. Okay, I don't care. Okay, so we just have to check each substring of length of S2 of length S1 if the count of its elements is the same as the count of in S1. We can just maintain, we first calculate the array for S1 and then using sliding window add S2 I sub S2 I minus 1 S1 calculate counts for window for each substring of length S1 in S2 and compare them in 026 01 each time. Smart. Obviously the 26 comparisons are useless. The 26 comparisons are the bottleneck. Notice that at most two counts change when moving the window. So if we keep count of equal positions before moving the window, we can easily check if the counts of S2I matched. Then we have to sub from matches, else if S2 or like window count S2I plus 1 is equal to S1 count S2I, meaning the adding the char is the last missing copy of that char. We add two matches count. Okay. One can the lower bound moving is left as an exercise to the reader. Then for each window shift we do O1 not O26 work n plus m where n is the length of and length of I should just type this S1 since we first get counts of since we first get counts of S1 and then just move window through S2 per shift. Space complexity is of 1 if we pretend that the size where k is the size of the alphabet, since we have to store counts of at most that many elements. Okay, and anyways, nobody gonna read it. Goodbye.